This is the title of the talk. Let me just see whether. Let me just do this simple way. Okay. In fact, I should first to tell you that Professor Salam was a wise man and also mentor in my career. I was really fortunate enough to spend, almost 17 years in Trieste, from 1986 to 2002 at ICDP. In fact, for these 10 years, from 1986 to 96, was really direct under Professor Salam's supervision. What I could witness, first is witness how he devoted his wisdom, energy, heart, and soul to materialize the dream of the developing world. The second thing I could witness is how his dream is coming true, at least partly, in some part of the world, including China, although the path is not straightforward, full of challenges and difficulty. I thought instead of just a general description, I will use some of my personal experience to tell what was the true story. In fact, a half-century ago, modern condensed matter physics was almost non-existent in China. The reason was very simple, because before 49, the basis for science was very weak because of war and because of many things. After 49, everything needs a boost. So, of course, a few well-known physicists come back, return to China, like Huang, who is the most known, and also like Madame Xie and others. But because of the Cold War, there's a total isolation from the rest of the world, This is the beginning, humble beginning. On the other hand, since the beginning of 21st century, Chinese condensed matter physics really entered the fast track. A number of outstanding young physicists with cutting-edge output emerging in the world arena. I will just give you a few examples later on. The question is, how did this quantum transition occur? This is the outline of my talk. As I said, at the beginning, in the 60s, there was a total isolation from the rest of the world. So the way out, those decided by Mao Zedong himself, is to learn from Soviet Union. So actually, China at that time changed the entire higher education system from the European, American to Russian, which of course was eventually influenced by European system. Then, of course, in less than 10 years, about 8,000 young people from China received diploma or PhDs in the former Soviet Union. In fact, many of them are still alive, are still playing a role, like myself, just in China. I was really fortunate enough to be one of them. I studied in Kharkov from 56 to 61. My thesis supervisor was my Isakovich Kaganov. And I should mention briefly that Kharkov is the city where Lev Landau created his theoretical physics school, not in Moscow, in Kharkov. Then, of course, there was a funny story why he left Kharkov, moved to Moscow. And after he left, his chair and the position was took over by Ilya Mikhailovich Lifshitz. This is Ilya, not Evgeny. This is a younger brother of this Lifshitz brothers. The senior Lifshitz was the old co-author of the theoretical physics group. And Lifshitz took over. However, the good fortune did not last too long, because China and the Soviet Union broke up. And there was Actually, my supervisor really wanted very much for me to go back to do PhD, but it was not possible. Not only about to return back to get PhD, and I was not allowed to travel for 17 years. And actually, only after many, many years, after 26 years, I met my former supervisor again, and in 26 years. So actually, what we did, I mean, in that situation of total isolation, is a kind of new start. I joined this institute in 1961, which is a very old institute, which was created in 1928. I should say the material conditions were rather poor. We could hardly feed ourselves, hardly. But the environment was really encouraging. Actually, I was appointed as a group leader at the age of 24 without PhD degree. Actually, the good thing is under that condition, I mean, there was enthusiasm for learning and doing science. And the way, I mean, instead of supervision, we had self and mutual education. We had a group leader, which is 1 year and a half, 3 years older than me, who had the chance to go to work in Bogoliubov's group for a diploma for almost 2 years, Chen Zhenxie. Unfortunately, he passed away. The outcome was rather fortunate. Among that group of young people, 4 out of 5 later became the academicians of the Chinese Academy of Sciences. And actually, I mean, we started by learning and doing physics. Amazingly enough, some physics was done at that time survived 50 years or even more. I just want to tell you briefly the actual story. Actually, I was learning this theory and learning that. At that time was the hot topic at that time was the impurity effect on superconductivity. Anderson had the famous theorem that the non-magnetic impurity was not important. So, I mean, just then, because Anikakov really used the perturbation theory to show that magnetic impurity really just hurts, superconductivity. But they used perturbation theory. As a very young student, just ignorant, I thought there's a gap in the excitation spectrum. It's very much like semiconductor. So maybe there's a bound state in the gap. So that was curious. Then I did a kind of big exercise and really found this bound state in the gap. And this calculation were really just detailedly debated in our group. And people said, it's okay. You can go ahead. You can go ahead. Then it was published and so on. So that was later on was known as the so-called Bogoliubov-Dejean equation. And this is the bound state. They also calculated the absorption and turning experiment. It turned out that later on, 3 years later, and Kyoki Shiba from Japan and Sasha Rusinov from Soviet Union also did similar calculation. But that to check that experimentally is very, very difficult because this bound state inside the gap of superconductor with paramagnetic is very, very shallow, very, very shallow. So the bound state is rather big, so it's very difficult. So only the first signal was obtained by Professor Booker in 1981, and the direct observation was in 1997. Of course, no one knew that piece of work because it was published in Chinese and there was no exchange. But the amazing happened in 1994 when I visited Los Alamos. I talked with Sasha Balaski in the theory group, and he was really working on impurity effect on superconductor. I said, look, Sasha, I did this calculation some years back. So I gave him this paper. He has some Chinese student translated this for him. So he was very kind. So all the publicity about his work just because of him. Then he really quoted that paper in many others. So this was the first experiment. And later on, my Chinese colleagues did a much nicer, more precise experiment to these things. Amazingly, this effect is turned out to be relevant to the hot topic today of the Majorana fermions. Because there's really a hunt for Majorana fermions in condensed matter physics, and this is a fermionic particle, which in this P wave, superconductors. So, and this was a prediction by Liang Fu and Charles Kahn, in 2008, and the Princeton group claimed that they really, found these things. Of course, there's still dispute because this is a very difficult experiment, and they really, show, this they call this U-Shiba state. And very recently, last year, end of last year, this collaboration of French and the Russian group, they did even more, nicer, more careful experiment for two-dimensional systems. We know that in two-dimensional system, instead of exponential decay, you have the power law. Then, of course, the bond state is much more robust. And it seems that this might be a good candidate for really, hunting the Majorana fermions. The reason I just tell this story is that was the condition under which we worked and we tried to do things. But that one also lasted not long. Actually, there was Cultural Revolution. And what I did, Cultural Revolution was sent to the country, was sent to the countryside, to the manual laborers, of course, not benefit physics. But I want to tell you that even within that period, there's some chance, some just improvement of local environment that you can still do some physics. And what happened is, and Xian Yang and T.D. Lee, they started to visit China in 1971. In 1972, Frank went back to China again, and he gave lectures. And first time he was received by Mao Zedong himself. Second time he was received by Zhou Enlai himself. And the president of Peking University, Zhou Peiyuan, was present at this meeting. After the meeting, Zhou Enlai wrote a long article originally was submitted to the Chinese daily, the People's Daily. It was not allowed, then it was published in so-called Guangming Daily. That was very important because we intellectuals, have very sensitive notes, and we somehow spared out. This might be some good chance to do something. So we thought we should go back to do some basic science. Just incidentally, my colleague, Hao Beilin, and in 1972 joined a small delegation, 4 people, to attend the annual meeting of the Canadian Association of Physics. At that time, there was no exchange between China and the US, but Canada is slightly different. So he could hear Michael Fisher's talk about Ken Wilson's work. Of course, he could not catch the essence, but he at least heard these few words, key words, and that was really helpful. So we rushed to the library. The very, very fortunate thing is that during the Cultural Revolution, although these journals were not displayed at all, they were received, they were still remained bonded and left somewhere at the corner. Just we opened that, just dig that, then it was really, surprising that this enormous progress on phase transition and critical phenomena. So you can imagine, this is, we received some, higher education, abroad or whatever. Certainly you feel that you don't know the really basic things. So the strong feeling of lagging behind. So the only way to make up with anxiety, the only way to do that. So just to study, to share all the important paper widely. So we have very intensive group seminars. And the lecture notes of the seminars is of that thickness. And of course, it's not just to learn. You want to do something. This is our way to do. And we just read paper one by one. And instead, we read a paper by Elihu Abraham and Srito on this skeleton graph the Parquet diagram calculation of the quick exponents. They claimed they could push to high orders. Then we thought, let's try to first understand that. So we really just did independent calculation to check that. That worked out, and then eventually we submitted a paper to publish. So this calculation is rather sophisticated. It's a Parquet diagram calculation and so on and so forth. But when we finished calculation, in 1973, by the end of something, we were happy, but we were discouraged because we saw in physics letter, 2-page letter by Edward Bazin and Songjin Stan and Legrand. So we thought again, since we were using completely different technologies. They were using Keller's-Semansi equations. We were using the standard pricing. And also we calculated these the specific component independently. So we decided still to publish. Another important event during this cultural revolution I want to mention, which was really important for change in my career, is in 1975, there's a big American delegation visited China. And it was a reciprocal visit of Chinese solid-state communication to US in 1975 earlier. But in this official exchange of letters, they really say that the solid-state physics delegation wished to make an in-depth study of major areas of solid-state physics research and teaching in the People's Republic of China from the exchange later in these things. And they visited China for almost 1 month. The entire procedure was really completely unusual for Western scientists. They had preparatory meeting in Japan before. And after 1 month meeting, they had this summary meeting again, and then they published the official report. I want to show you this was really the composition of this. There were 4 Nobel laureates. Half of them survived till now. And this is a book that we published, and it's more than 200 pages. And in fact, during that session, I really established personal friendship with Bob Schiffer and others. What happened is I happened to be his interpreter. He gave a talk on solitone. At that time, he did some really exciting work with Jim Krumhanser on solitones and I was his interpreter. But during the talk, he somehow forgot the key word himself, solitone. I just reminded him, like in the play. Just you have someone to say. Then he was really very kind. So this is an official comment they wrote in this book. So some theories attached to the magnetism group of the Institute of Physics described to us some rather sophisticated and innovative work on critical exponent near quantum transitions. This study used reversing group theory and the diagrammatic analysis, methods similar to those used in the most advanced contemporary work in the West and in the Soviet Union. And these studies were the most conspicuous exceptions, because everywhere in China, they talked with physicists, scientists. They always tried to do some practical work, phenomenology, useful for these things. So now I jump to later on. My fate changed us, all intellectuals in China. So I was allowed to travel. First trip abroad, I had the fortune to attend the Nobel conference in Brussels, which was a really very well-known conference, where really I met T. Anderson, the Cardinal, Michael Fisher, and many others. Then I went to Harvard to work with Bert Harper. Can you imagine? That was, it's really like a hungry and thirsty man. Just after so many years of isolation, you had chance of the access to the latest development in science. I was saying, jokingly, so when we were sent to the countryside, the official name was really re-education by the farmers, workers, and the soldiers. to me, I mean, the real education was at Harvard. Then, of course, Bert, introduced me to other colleagues, said, this is my senior postdoc. I said, look, senior is correct because he's 4 years younger than me. But I never had PhD. Then, of course, I then went to visit Bob Schiffer in Santa Barbara. He was very kind. I mean, he moved to director office in this new building, so he left the office in the physics building on the 6th floor, for my use during my visit. Now I want to tell you a little bit how I was involved at ICB and how that really completely changed my life. For that, I need to mention two wise men. It is Stig Lundquist and Abdus Salam. Of course, maybe I need to say a few words about Stig. In fact, in the early days, John Simon was the person who really helped Salam to build up condensed matter physics at ICTP. But later on, from late 60s onwards, Stig Lundquist was the key person who was also involved in Nobel Committee for many years. He was a very close friend of Bob Schiffer. And the surprising I met is that in 1983, he visited Institute of Physics. I never met him before. And after conversation, he just invited me immediately to visit ICTP, visit Chalmers, and visit Nodita, and to really start my involvement. Then in 84, my second visit to ICTP was as an associate. At that time, because of the increase of funding for ICTP, so IAEA approved to establish scientific positions for staff. In fact, and I was considered as the first one in condensed matter physics because there was no condensed matter physics. Because condensed matter was really relying on Elio Crosati, on Mario Tosi, and other people's help. So Stig just suggested me to take this position, and of course it was approved by Abdus Salam. In fact, before taking up this position, when I was still in China, I received a letter from Abdus Salam. The certain part of this letter. We would like the condensed matter activity in developing countries, this was underlined, to be enhanced through your presence here at the center. This would mean, but actually he said that for building up in developing countries, the solid-state communities where they do not exist. And also, second thing is to emphasize the importance of applications. He said that very seriously. He said, finally, for my humble sake, this continuation of the position depends on the success which is achieved in helping with the objectives in respect of enhancing studies of this in developing countries. And finally, he said, we all look forward to a second revolution in the condensed matter activity in developing countries with your appointment and so your influence. Can you imagine an inexperienced person receive the letter of this weight? Of course, I felt, profound respect to Salam. At the same time, it's also an anxiety, because I should tell you that I hesitated to show this letter to anybody, even to my best friend, Elio Tosati. I never dared to really show this letter to other people, because I really was afraid I will not be able to really fulfill the task that Professor Abdus Salam just entrusted to me. Actually, I want to return back to the reality. That I should say that very honestly, that ICDP CISA really have played a crucial role in helping China to train young physicists and to integrate them into the world scientific community. Because in the 60s, in the mid-80s, at the beginning of the opening up, I mean, there was not so much exchange channels with outside world. So ICTP was really the stepping stone for many, many Chinese scientists, including condensed matter, high energy, and mathematicians to go abroad, I mean, through ICTP. And of course, many senior people, my colleagues, and also a number of current leading figures really just have grown through from this training. This is some statistics. Altogether, there was, this is up to 2012, and more than 5,000 visitors and almost 200 associates, and 40, I mean, the fellows. I think after this period, I said that I hesitated to show this. I really tried to follow Professor Salam's teaching and follow his supervision. So I should say that the work during my tenure interest was well recognized by our colleagues. And then in 2007, I was awarded the American Institute of Physics, the so-called TED Medal for International Leadership in Physics. But this is a limitation. This cannot be awarded to Americans. It should be non-Americans. And this is the citation. The thing I want to mention is Professor Abdus Salam also received the same prize in 1978. I feel really honored and pleased. In fact, I was really trying very hard to really follow his steps. So now I want to say a few words about the current development and some remarks. And in fact, many years of concerted efforts have produced some visible results. And one example is in 2008, it's just a heat wave of the iron-based superconductor. That superconductor was not discovered by Chinese physicists, but Japanese physicist Hosono-san. But then the big push was really made by Chinese scientists, and this is the opinion of the scientific community. I want to quote some very recent examples. In 2015, there are two news reports. One is made by the European Institute of Physics. There's a top 10 breakthroughs in physics. And the top one is also from China. So this is from this strong group of Jianwei Pan. And this is so-called double quantum teleportation milestone in physics. And because the first time materialized the entanglement of 2 degrees of freedom on one photon, including both the spin and orbital momentum, which really is very important in the community. And among the top 10, there's another one, is a where fermions are spotted at long last. And it was done independently by 2 groups. One group in Princeton, one group in my Institute of Physics, and were independent. Then, of course, the American Physical Society also published these highlights of the year. Altogether, they picked up 8. And this is the logo, of this discovery. And this is also one of them. So I just to mention, what is the story? The story is that Dirac made this paper in 1928, and made this paper in 29. Of course, at the beginning, they thought this might be relevant for neutrino, and it was a really good candidate. They realized that neutrino has mass, so it is not. Then, of course, people really realized this might be use condensed matter system to really find this wire fermion as a quasi-particle, as excitations. And in fact, I want to say that the entire circle of work, the theoretical prediction, the material preparation, and the experimental characterization were done at my institute by just several different groups, jointly. So this was really, I don't want to go to, into details. So let's just look, at large. 30 years ago, when TWAS was established, the developing country with 80% of world population were producing only 5% of scientific publication. So this was the divide between the developing and developed world, which worried Abdus Salam so much. And then what happened at that time, the research and development budget in development was only, in average, 0.25%, whereas in the developed world is 2.5%. In actual money, it's 2 versus 100 billion US dollars. But in 2010, according to the UNESCO report, scientific output from 7 developing countries, which consists of 2/3 of the entire developing world, and it's already grown to 32%. 32%. And China alone has 10%, more than 12%. And China is becoming number 2 after the US. But the very recent data, if you look at the Web of Science, if you search physics and the Republic of China, the citation, the ACI papers in China already exceeded US in last year. Of course, one says that maybe quality should be more important. So it's quality. And the nature, you know that they introduced this nature index. They use 2 different panels of experts. Selected 68 journals. They have different called the article count, this fractional count, and also weighted count. And by the end of last year, they published some interesting findings. That if you look at in fact, this China is for this from 2012 to 2014. China's this nature index increased by 37%, whereas the U.S. dropped by 4%. And this is in the chemistry, and you can see, these two curves. And so, of course, one can ask, what are the factors? I just mentioned very briefly. One of the importance is really sustainable government support. For the last 10 years, the annual growth to scientific investment is of the 10-15% increase every year. Now, in 2014, the R&D is already 2.1% of the GNP. And then the training and the backflow of the manpower. You probably have heard this so-called Southern Talent Program, which attracted already 5,000 well-qualified experts to China. And then now, there's a big investment into the big facilities. And apart from that, there's also consolidation of the scientific community. So finally, I want to mention that, really to say that Professor Abdus Salam's dream partly comes true. And I would like to report here, to him in the heaven, that he can rest with peace. At least, because I should say, at the beginning, many people really said, this was unrealistic, because at the beginning, at the inauguration conference of the TWAS, so of course, we all remember Salam's deep belief that the knowledge, scientific knowledge, is the common common heritage of the world. And in that speech, he really important that the men and the women of the Tibetan movement who really wanted to contribute on equal terms with people in development. That dream, I think, is partly materialized. At the very end, I want to share with you a good piece of news. Is that the Chinese government has decided to propose to UNESCO to create the International Center for Theoretical Physics Asia Pacific in Beijing, China. And with the help of Fernando Quevedo, and this has been progressed quite well. And this is a letter of the Director Secretary General Irina Bokova to the President of the Chinese Academy of Sciences, Professor Bai Chunli. And this has been already approved by the Executive Board. And this center will be created in Beijing, in the north part of Beijing. And it's about 50 kilometers away from the center. And the landscape is quite nice. I mean, from the satellite point of view, I mean, just not far from the center is a very nice lake where this APEC conference took place last year. Yeah? And also there's another water reservoir. And this is, I think, scientists in China really felt very happy because China, as a #1 economy, development, should really bring its own contribution to help to developing countries. This is a kind of important step towards that end. Thank you very much. Thank you very much.
There is time for questions or comments to Professor Yu.
So this new proposed center would also function like ICTP, where people would come and stay a couple of years.
The difference is this will be really not type 1, but type 2 center under UNESCO.
So what's the difference between type 1 and type 2?
Because it has some higher autonomy.
Type 2 has higher autonomy?
No, number 2 is higher autonomy.
Yeah. And funding will come from...
Because in this type 1 center, Fernando is here.
Is here, yeah.
Yeah. Most important thing has to be approved by UNESCO. While this is the type 2 is really associated with UNESCO with the support. But of course, the funding will be provided by Chinese government. But we will really follow exactly, the road and experience of ICTP Trust.
But ICTP stands for International Center for Theoretical Physics. You will have a different name?
Yeah, International Center for Theoretical Physics Asia Pacific.
Asia Pacific.
Yeah, half an Asia Pacific.
I see.
We already have one similar Asia Pacific Center in Korea.
Yes, this is called APCTP.
That's right, APCTP.
Yeah. But this is slightly different. Slightly different. Because this is really part of this UNESCO systems. At that time, I understand. Korean colleagues also tried very hard to do this. But at that time, it was not clear which way to pursue. But because of Fernando's help, we found this way.
I just wondering what is the relationship between the new proposed center and the APCTP? Because I was heavily involved with the formation of APCTP.
No, this is a collaboration.
Yeah. No, at that time, when we proposed APCTP, we actually asked the Chinese colleague, but they say it's difficult to have
But
it
no,
in
actually,
China.
China is part of this. China is part of, is on the council and all, everything of it.
I'm just trying to say the Chinese colleague at that time, when we proposed the APCTP, that's more about 20 years ago. They were saying that there was a lot of problem. Thank you.
Further questions or comments?
What's the annual budget for this new center?
This is in the starting, just approval page. I would not speculate. I think it should be not quite substantial. Should probably have. Because China already made, donation to us and also to. In fact, the University of the Chinese Academy of Science is hosting many PhD students and postdoc from developing at the moment already. The campus in Zhongguancun is mostly occupied by these foreign students.
I don't see any further hands, so let's thank Professor Yu again.